So next we are moving to flame photometry or flame emission spectroscopy. Flame photometry, it is the working principle is like a flame emission spectroscopy. First we have to convert the metal into the gaseous state, or otherwise when we are aspirating the metal into flame, it shows a particular color, or otherwise each and every metal when we are showing a flame means it shows a, or otherwise it generates a particular color in the flame. So based on that, when we are putting some metal or aspirated the metals in a flame means it absorbs the thermal energy and it goes to higher excited level, energy level. After that, it in higher excited energy level it is an unstable. After particular time it comes down. So during when it comes to again ground state, it emits a photon. So based on that photon is emitted, we have to measure how much radiation it's emitted, and then we have to measure that electric current produced in a amplifier. So simple. There we are using an UV or visible radiation in atomic absorption spectra. Here we are using an thermal energy. So the thermal energy helps to excite the molecules to higher energy level. After there it is an unstable. So when it comes down, that means it emits a light. So we measure the concentration or otherwise the absorbance of that radiation. So emission of that radiation. Then we measure the concentration of given sample. So this is the principle of flame photometry, that means absorbs thermal energy and goes to higher energy state. So after that it comes down by emission down to ground state electronic energy level. By emitting radiation. So we have to measure the emitted light. So this is a simple principle of working principle of flame photometry. So next we are going to see the block diagram and also instrumentation of flame photometry. So here it consists of flame producing area, that means burner, and also it consists a lens or otherwise filter. We have to say it as a filter, and then filter, and then photo cell and amplifier and recorder. Before feeding a sample into burner, we have to convert into a droplets. So there we have to sample, and to nebulize it we have an air. So there we are nebulizing it. The nebulizer means we are converting the liquid sample into a droplet, and then we are feeding the droplet into a burner. So there the solid metal particles are converted into gaseous state. So first we have to check that burner area. So the flame is produced in burner should do the following functions. That means first the flame should evaporate solvent present in it. That means if the test solution contains solvent means it should evaporate the solvent. And also next second point, here the flame should have tendency to break the solid molecules into gas, and then after that the gaseous molecules are dissociated into atoms. And then in third point, the given energy to the flame should excite the dissociated atoms into higher energy level. Excite dissociated atoms to higher energy level where it comes down. That means if you are exciting that electron into higher energy level means that state should be unstable for that element. So it's probably to comes down, that means comes to the ground state, to cause them emit radiation. To emit radiation. So next we are using reflector or lens. So the function of reflector and lens is the flame should emit the radiation in all directions in space in order to increase the amount of radiation reaching to the monochromator and detector. A concave mirror is set behind the burner. That means next we are using filter. The filter allows of certain wavelength only to the monochromator, and other radiations are absorbed by filter. After a particular radiation wavelength is selected, the wavelength fixed radiation is strike to the photocell. There we have to convert the photons into an electric current. Then the electric current is sent to amplifier. There the electric pulses are amplified and data is recorded. That's all about the working principle of atomic absorption, that means working method of atomic absorption spectroscopy. Here a fine mist is formed, that means in atomizer a fine mist is formed, and then the air mixing the air and also sample mixer is then sent to the mixing chamber, where it mixes with fuel and burnt in the burner. So next we are, by using a flame photometer, we are measuring an sodium concentration, because it's widely used in table salt and also in so many purposes. So we have to measure that sodium concentration. First we have to prepare a stock solution. So for preparing a stock solution, we can't get a sodium as a metal, but then if we are putting sodium metal into a water, means it starts to fire. So we are taking sodium chloride. So by dissolving 2.542 gram of sodium chloride in 1000 ml water, means it contains 1 ml of water contains 1 milligram of sodium. That means the total water contains 1000 milligram of sodium in 1000 ml, or otherwise we have to say 1000 ppm. That stock solution is in 1000 ppm by dissolving 2.542 gram of sodium chloride in a 1 liter water. After that we have to make a dilution for a proper required volume by proper dilution. So the stock solution, that means different standard concentrations is either be 1 ppm to 1 ppm, 2.5, 5 ppm and then 10 ppm. In this range we are increasing the concentration of diluted standard solution. After that we have to the standard sample solution is fed into the nebulizer. There the droplets is formed by in the form of fine mist. After that we have to send it into the atomizer. The fine droplets are converted, is solid samples are converted into gaseous state. Then the burner, when fed to the gas into the flame, there the lens and filter photo cell are starts to function based on that radiation emitted from a flame. So we have to measure the data from a recorder. We have to plot a graph. So we know the concentration of sodium because we fixed it. So we are taking it's a milligram, that means ppm. After that we have to take intensity of emitted light. If concentration is higher, means the emission is also higher. So we have to get a straight line curve like this, and then we have to check the intensity of emission, that means emission for an unknown sample. In that point we have to extrapolate a graph, and then where it cuts the straight line, that means where it cuts the data line, and we comes down to the x-axis, and we can easily find out the concentration of unknown sample given for your testing knowledge. So next we are moving to surface characterization technique. Because if we are preparing a material, means we should know the its surface characteristics or surface morphology. It helps to identify the properties of that material in the form of either it can conduct or otherwise it cannot be conduct, or and then its physical and chemical properties, that means melting point, boiling point, and then if the surface is rougher, means it can used for catalytic activity, and sometimes we need a smoother surface for alloys and also glasses. So different instrumentations are used for this surface characterizations. First one is an XPS. The abbreviation for XPS is an X-ray photoelectron spectroscopy. And next one is an Agar electron spectroscopy, AES, Agar electron spectroscopy. And then AFM. And then in microscopic methods we are using some of the microscopic techniques to analyze the surface morphology of materials. AFM, SEM and TEM, and then to analyze the pore size of selected material, we are using a BET method, BET analysis method. Here we are passing a nitrogen gas in it, and then based on the absorption of nitrogen gas, we are calculating that surface area and also pore size of that given material. So these are all microscopic, and then STM scanning tunneling microscope also we are using for characterizing the material. Here in the XPS and AES and also these microscopic techniques, we are first passing and higher energy electrons into the surface layer. It hits the surface of material, and here it produces the secondary electrons or comes out from a layer of an material. The given energetic electrons are only hits up to 2 to 3 atomic layers of given material, that means synthesized material. After that, the secondary electrons are measured by the detector. So here we have to analyze based on that emission of secondary electrons and also the frequency of formation of secondary electrons or the frequency of secondary electrons. We have to detect the morphology of surface structure of crystals or otherwise synthesized materials. So the measuring that surface methodology is very specific or comes under very advanced in a recent studies due to know about that particular size and pore size, reflectivity, and then surface roughness. These are all very important parameter to know about that property of that element, and these are all helps to determine the physical and chemical properties of given sample. So thank you.